Okay, you guys, so we're going to go ahead and we're going to go through some of the chemistry stuff. I'm going to start by going through the first study guide, and then I'll move over onto the second study guide. So I'll go through this one a little quicker, and then we can go ahead and we can get this thing going. So with reference to scientists, you have a couple of scientists that we're talking about. We have Democritus. He was a Greek philosopher. And the main thing about him is that he came up with the concept of the atom. So this guy is just concept of atom. And he said that they're like whole pieces and they can't be destroyed. So that was his like deal, is that it was like a whole piece and like you can't destroy it. Dalton, very similar. He said that they were whole. And he also said that they were like, he came up with the idea of like subatomic particles. Atomic particles. And his idea was that he saw that for the mass, like they're usually like whole numbers for the atom. So they're pretty close to whole numbers. So that was his idea on it. Thomson, on the other hand, he saw that some of the atoms were actually charged. So his idea is that some atoms are charged. So his initial thing is that it wasn't just protons and neutrons like we had here. In this case, we had protons, neutrons, and electrons. And then Thomson is also credited with the chocolate chip cookie model. Chocolate chip cookie. And what I mean by that is that we have a big like positive deal with the protons and neutrons, and then the electrons are kind of like a mixed in. So that was his idea. Rutherford was a little bit different. Rutherford went ahead and he had his gold foil experiment. And in his experiment, what we saw was that some atoms bounced back. And what this means is that there was like a small and dense nucleus. So he came up with the idea of the fact that there was a nucleus. So those are pretty much like history-wise, those are like the people that you guys do need to know, as well as making note of that gold foil experiment and Rutherford. Okay, so we have the amount of protons, neutrons, and electrons according to the periodic table. So first of all, how do you find the amount of protons? That is going to be your atomic number, which should be your number at the top of the periodic table. Your neutrons, in order to go ahead and you find your neutrons, you take your atomic mass, and then you subtract that by your atomic number. This one, how do you find the amount of electrons? If it is neutral, which means no charge, then we would go ahead and we would be the same as your atomic number. So it would be the same as your atomic number if you have no charge. So that is your thing on that. Then you guys would go ahead and you guys would look this up. So for carbon, it's 6, 6, and 6. For oxygen, you should have 8 all the way across. Yes. So 8, 8, and 8. For nitrogen, same deal, 7, 7, and 7. Magnesium would be another one that's 12, 12, and 12. Right, calcium, another one, which is just 20, 20, and 20. And again, how I get these numbers is, for example, I go 12 minus 6, and I get that. Right, for oxygen, I go 16 minus 8, and I get that. Right, for nitrogen, it's 14 minus 7. For magnesium, it's 24 minus 12. Right, and for this one, it's 40 minus 20. Right, and so that's how I get the number of neutrons. So it's not always the same, but in this case, it is. Okay, so an isotope. An isotope is basically atoms with different numbers of neutrons. So that is going to be your thing on here. And the way that you guys go ahead and you guys look at this, right, is that this one is your atomic mass. Oopsies. And then this is your atomic number, right? And then this is your, obviously, your symbol. So you guys are going to go ahead and you guys should be able to compare and contrast as well as write these things, right? So the element in this case is going to be carbon because that is what we get from the letter C. The number 6, right, refers to our atomic number. If you also write number of protons, that's fine too because it is our number of protons. The numbers 12, 13, and 14 refer to this atom's atomic mass. What you guys will see is that for isotopes, it is for this atom specifically has 13, right? A mass of 13, which means a total of 6 protons, and whatever is left over is going to be those extra neutrons, right? So they ask us how many protons and neutrons are in the first isotope. So protons would be 6, neutrons would be 6. How many protons and neutrons are in the second one, right? So I have 6 here and 7 there. And then how many protons and neutrons in the third isotope? I have 6 there and I have 8 there. And again, how I get this is I'm going ahead and I'm using that 14. I go ahead and I subtract 14 minus 6, and then I go ahead and I get my 8 neutrons. So that is how I'm getting those numbers. Okay. So this thing is going through the different types of decay. So in alpha decay, what we have is we have a helium nucleus that comes off. So that is what you guys have in alpha decay. In beta decay, right, we have a neutron that goes into a proton, and we lose an electron. So there's a couple of things that happen, right? And in gamma decay, a photon comes off. And what I mean by a photon, it's just a unit of energy. So a unit of energy just kind of comes off. And it usually happens because the protons and neutrons are like shuffling a little bit, and it goes ahead and it does it, right? So the power of each decay, so gamma is the most powerful, and it can only be stopped by lead. This one is the weakest. Alpha is the weakest, and it can be stopped by paper, right? Beta is in the middle, right? And beta can be stopped by foil. So if you just had a piece of foil up, you can go ahead and you can block beta radiation. And the main thing on here is that you know that there's different types of radiation, and that gamma is ultimately like the most dangerous type of radiation that you guys can have. Okay. So for your atomic radius, right? So for your atomic radius, you guys, on your periodic table, so if I just kind of sketched out a periodic table, what you guys will see is that your biggest atom should be right over here, and this atom right here is actually francium. So the closer you are to francium, the bigger it is. So it goes down the group, and then it goes like back left across the period. So it goes down and then left. Right, and then on the test, like make sure that you know your trends, because they will ask you to go ahead and to kind of compare and contrast the two. Okay, so an ion is a charged atom. A cation is positively charged, and then an anion is negatively charged. Okay, so the next one is we're talking about ionization energy and what is the trend and pattern on the periodic table. So again, if I were to go ahead and if I am talking about ionization energy and electron affinity, It is actually the same trend for both of them. And then we'll talk about the difference between the two. So for electron affinity and ionization energy, they follow the same trend. So as you go right across the periodic table, your electron affinity and ionization energy increases. And then as you go up on the periodic table, you guys also see an increase as well. The main thing to note is that this trend does not include noble gases. So not include the noble gases, which is that last group on the periodic table, which is group 18, right? Right, you guys are not including these guys. So in this case, right, it's going to be this next top atom. So it's going to be fluorine. So fluorine has the highest electron affinity and ionization energy. So when we're talking about electron affinity, we are talking about pretty much how much you love electrons, right? When we're talking about ionization energy, it's going to be like how much you're willing to lose an electron. Willing to take electrons. Right, so those are your two things on there. Give me one. And then last but not least, you guys have convection, conduction, and radiation. And just one thing on this, right, just remember that the closest you are to fluorine, right, the more likely you are able to exhibit those ionization energy and electron affinity. Okay, so convection. Right. Convection is basically we have two things going on. We have heat that rises, right, and it rises to the top, right. So something that gets go ahead and it like has fire and it gets heated at the bottom, and then what happens is at the top it cools, right. So at the top it goes ahead and cools, and then it begins to sink, right. But if you have if you have a heat source that is at the bottom, right, what will happen is that it will continuously like go through that convection cycle. So it'll continually rise, and then it'll go ahead and then it'll sink, right? So convection can occur. When I'm talking about this, I'm talking about that it can occur in liquids and gases. So that's kind of like the main thing that you guys need to know is that it goes ahead and occurs in liquids and gases. You also see it on Earth. So make sure that you guys go back and kind of like review some of the Earth science stuff. So see how convection is going ahead and it's being related to earthquakes. Okay. Conduction. So conduction is when heat is going ahead and heat is passed by direct contact. So for example, if you guys are able to go ahead and if you're able to touch something metal, right, over time, the heat from your body goes ahead and it transfers into the metal, right? So those are kind of like your examples of your convection, like how it can occur. In this one, again, this one can happen in solids and in liquids. Not so much in gases, but it's possible to see it. Okay, but you need that contact is like the main thing. Okay, and then radiation is just like heat passed by waves. So with your heat that is passed by waves, just make sure that you guys don't need like a medium. So this one can occur like anywhere. Like you don't really need like a medium to go ahead and do it. So you don't really need like gases or something for radiation to happen. You just need to make sure that you know that it's like passed by a wave. Okay. And then last but not least, how do molecules move in solid, liquids, and gases? Right. You have to make sure that you guys know that in solids, right, the molecules are very tightly packed together. In liquids, right, the molecules are a little more loose. Right, so if I had the same amount, they're like still there, they're just like not as tightly packed, right? And then in gases, they're completely spread out. So you will know that gases are also like moving, right? You guys should also know, right, that this is like the slowest. Whoa. And then that is like the fastest. And the slowest to fastest also correlates with temperature, right? So this is like the coldest, and this is the warmest. So those are a couple of things that you guys should know on there. Okay, so that is kind of like your first part. We're going to go into part 2. Part 2, we kind of already went over this stuff, but I'm just going to kind of quickly review some of these things. I have some people that are requesting me to kind of go over conversions again and some of the density problems again. So for now, I'm going to kind of just briefly gloss over some of the significant figures, and then I will go ahead and I'll go through some of this conversion stuff. Okay. So for significant figures, just make sure that you guys are able to put everything into 4 significant figures. Also, just make sure that you guys are able to go ahead and to go through this stuff and know that since this is a whole number, right, and it does not have a decimal point at the end, right, there's only 3 significant figures, right, and then this one, same deal, it's 3 because there's 0, right, and this one is 1, right. All of these things are considered trailing zeros, right, and the trailing zeros are not significant, right. On here, right, what you guys will see is that we have this deal happening on here, and when we're going ahead and when we're looking at this, all of these zeros right here, they're placeholders, right? So there's only 1 significant figure here. And again, same deal. All of these guys are placeholders, and there's only 1 significant figure there. Okay. But on this one, you guys will see that these are sandwiched, so there's actually 4 significant figures. When I'm asking you guys to go ahead and to create 4 significant figures, right? So for example, if your answer is 20.0, right, you'll see that this is only 3 significant figures, right, because any 0 that's after the decimal point is considered significant, right, unless you have the zeros that are in the front like that one, right? So in order to make it 4 significant figures, sometimes you will have to add a decimal point and a few zeros to go ahead and to make it those significant figures. So I'm going to go through a couple of these conversions again because I have some people that are a little bit confused on that, and then we will go ahead and we'll go from there. Okay, so the main thing to know about these conversions is that you guys do need to know the rules for conversions, and you guys need to know this deal. So the whole King Henry died drinking chocolate milk, right? And it's super important that you guys know what each of those things mean, right? So this K right here, this is kilo, right? This is hecta, deca, my bad, deci, centi, and milli, right? So those are your different prefixes. In the middle, what you guys actually have are your base units. So you have grams, you have meters, and you have liters. So those are your different things in the middle. Depending on what the problem is, sometimes you will have to convert, sometimes you won't. It really depends on what units you're looking for, and I will talk about exactly what units you're looking for as we get through each of those problems. The next thing to know is what each of the values are that are attached to these things. So each of these have values that are attached. So kilo is actually 1,000, hecta is 100, deca is 10, right? Deci is 0.10, centi is 0.01, and milli is 0.001. Right, so this one is kind of 1 over 1,000. This is 1 over 100, and this is 1 over 10. Right, so those are going to be your different things that you see on there. So basically, when you guys are doing conversions, what you guys are going to be doing is that you are going to be moving your decimal point. So your most common conversions is going to be like milligrams to grams, or liters to milliliters, something like that. Those are going to be like your most common ones. So I'm going to do a couple of them, and we will go ahead and we'll talk about these things. Okay, so for example, if you had 100 kilograms and you're going to go to grams, what I do is that I go ahead and I take my number, which is 100. I put a decimal point right at the end, right? Then I go ahead and I find my K right here. I'm going to go ahead and I'm going to match it with one of these guys. And I see that that is that same K right there. And I'm going to grams. So I want to go from this K to grams. So what I do is that I go ahead and I count how many spaces that is over. 2 and 3. And I do the same thing with my decimal point. I take my spaces, my decimal point 3 places that way, right? So I'm going to go 1, 2, and 3, right? And I go ahead and I add my decimal point. So then I would go ahead and I would fill in those zeros. And then so my new number would be this, grams. And so that is kind of like the thing that you guys are going to be looking for, is that you guys are going to be moving the decimal point in the same direction. Okay, so that is going to be this thing on there. So just make sure that you guys are moving the decimal point. The other common conversion that you guys are going to have to do is liters to milliliters. And it's pretty much the same thing. So if I say that I have 15 liters and I have to go to milliliters, right? What I'm going to do is that I find liters and I see that my liters match here. And then I'm going to go to milliliters because that M, right, matches that. Okay. And I'm going to count how many spaces I have to go ahead and go over. So I go 1, 2, and 3. Right. So I do the same thing. I get the 15. I put that decimal point right there. And then I have to move my decimal point 3 spaces that way. So I go 1, 2, and 3. And I go ahead and I add those zeros. So my answer would be 15,000 milliliters, right? And it's not always that the decimal point moves in that direction, right? So we'll do a couple of other ones in which you guys will see that the decimal point can move in another direction, right? And it's not always 3 spaces either, right? So in another example, if I wanted to go from milliliters, and let's go ahead and let's go to kilometers. Okay, kiloliters, right? So if I want to go to if I have 5,000 milliliters, I want to go to kiloliters. So what I'm going to do is I go ahead and I start on milliliters, and my milliliters are right over here, right? And I have to go all the way to kiloliters because that's what my K means. Right? So I have to go ahead and I have to count how many spaces I'm moving over. So I go 1, 2, 3, 4, 5, 6. Right? So now I know that I'm moving 6 spaces that way. So I'm going to do the same thing when I write my number. I go ahead and I write 5,000. I go ahead and put a decimal point at the end. Then I'm going to go 1, 2, 3, 4, 5, 6, right? So I go ahead and I'm going to rewrite that, and I'm going to add some zeros on there and then put my decimal point on there. So then my answer, whoopsies, would be this. So I count 1, 2, 3, 4, 5, 6, right? And I have that, and that would be in kiloliters. Right. So again, right, you have to always be careful about where you guys are starting, where you guys are ending, and make sure that you guys are kind of following those different rules. Okay. So next one is density. And some people want me to kind of overview the density stuff, and I'll do a couple of problems as well, just to make sure that we are solid on this. But first and foremost is the basics. Right. Again, you guys are going to have to know how to use this. So just make sure that you guys do know how to go ahead and how to do this. Okay. So the triangle is just an easy way to kind of help you break down the equation. And there are different portions of that. So we will kind of go ahead and we will go over this. Okay. So For your triangle, we have D is equal to M over V. Right, so going over what each of the variables mean, this is mass, and mass is going to be expressed in grams. So make sure when you guys are doing these problems that you guys are looking for your mass being in grams, right? V is going to represent our volume, and volume should be in milliliters, right? Milliliters are also equal to centimeters cubed. So just make sure that you guys are kind of looking at that and making sure that you guys know that those two things are equal, right? Density is going to be represented by your letter D. And density is going to be mass over volume. Right? Yeah, so mass over volume. And what you guys will see is that for your units, you'll have grams per milliliter, right? So whenever you get your answer for density, that's what you guys are looking for. You guys are looking for grams over milliliters. So make sure that when you guys are reading, when you guys are doing it, if you see kilograms for some reason, right, you guys are going to have to go ahead and have to convert, right? So those are your different things on there. Okay, so this triangle, ultimately not useful if you guys do not know how to use it. So a couple of things on here. So this triangle goes ahead and gives us the three formulas that we use for density. So if you go up and down, you guys are going to be dividing. If you go, so that is up and down, right? You guys are going to divide. If you guys are going ahead and if you guys are going from side to side, you guys will see that it is going to be multiplying. So you're going to multiply if you go side to side, right? So how do I figure out if I'm going up and down, side to side? So what I do is that I'm going to go ahead and that I'm going to, whoopsies. So what I'm going to do is that I'm going to go ahead and I'm going to cover, right, whichever thing I am not using. So say if I'm looking for density, right? So if I'm trying to go ahead and my problem tells me to find density, what I do is that I go ahead and I cover my D, right? I pretend it's not there anymore. And then I go ahead and I look at what I have left. I have my M and I have my V left. And since I'm going up and down, I'm going to divide. So my first equation would be D equals M over V. Oh, that's wonderful. It just reappeared. Okay. Next one, right? If I go ahead and I look at this and then I'm like, okay, I need to go ahead and I need to find mass. So if I need to find mass, I'm going to go ahead and I'm going to cover up mass real quick, right? I see that I have D and V and I see that those things are going to be across from each other. So then now I have mass is equal to D, right, multiplied by V. So that is what my mass is going to be equal to. So those are going to be your things on there. And then I will go ahead and have my mass again, right? Then last but not least, if I'm going ahead and I'm going to try to find volume, I'm going to go ahead and I'm going to cover up my volume. So I go ahead and I cover this up and I see that I have mass and density left. So I go ahead and I have V is equal to M over D. And again, please be super duper careful about going ahead and making sure that you guys are dividing by the right things. Okay. So just a couple of example problems just to kind of get you guys comfortable with this, right? So if I'm looking for density, so if I say I want to find the density of an object that is 50 kilograms and it has a volume of, let's say, 5 liters. Yeah, let's go liters, right? So I can show you guys conversion, right? This is what I'm going to do. So I go ahead and I'm looking for density. So that means I'm looking for D. So since I'm looking for D, I'm going to use the same formula. D is equal to M over V. So I go ahead and I'm going to go D is equal to M over V. I have 50 kilograms and I have 5 liters. Now, if I went 50 over 5, right, and got 10, right, that's going to be wrong, right? That's not going to work. So what we have to do is that we have to go ahead and we have to convert this, right? So we have to go 50 kilograms to grams. So I go King Henry died drinking chocolate milk, right? I want to go kilograms to grams. I know kilograms is here and grams is there. So I go 1, 2, and 3, and I'm moving 3 spaces that way. So I have 50, right? And I'm going to move 3 spaces that way. And so my new number should be 50,000 grams. And now I have liters, and I have to go to milliliters, right, which is over here, right? So I'm going to go ahead and I'm going to move 1, 2, and 3 that way. So then I go ahead and I go 5, and then I'm going to go 1, 2, and 3. So I go ahead and I do that, and I get 5,000 liters. So then what I would go ahead and I would do is I go ahead and divide the deals, and what I would get is 10 grams over milliliters. Okay, so that is how you guys go ahead and get that thing going. So that is pretty much what you guys have to remember for the density equation. So the density equation, not too bad. Just remember to be on the lookout for conversions. This one actually happened to work out so that they're both kind of 10, but it doesn't always work that way. So just kind of be wary of the math and being wary of when you guys do have to convert. Okay. So that part is density. Next big thing is the heat equation, right? So for the heat equation, we have Q is equal to MC delta T. I'm going to give you guys some like tips and tricks sort of deal, and then we will go ahead and we'll work on some of the ones that we didn't solve during class to go ahead and to kind of have a few examples on there. Okay, so Q. Q is just heat. So just make sure that you guys know that Q is heat. And heat is going to be expressed in joules. So that is going to be your J. M, again, is mass. And that is going to be expressed in grams. C is specific heat. And specific heat is expressed in joules over grams degrees Celsius. Right, and then delta T is going ahead, and this is change in temperature. And your change in temperature, it's going to be T final. So whatever you get as your ending temperature, and then minus T initial, which is your beginning temperature. Right, so those are your two things that you guys have on there. So those are going to be your change in temperature. And you guys will see this in degrees Celsius. So whenever you see a degree Celsius, if you have 2 of them, you have to make sure that you guys subtract. If you guys just have 1, right, you guys are just going to go ahead and see what that change in temperature is. Okay, so that is pretty much the equation. Really make sure, again, that you guys have everything in the correct units. So joules is on there, grams, right, degrees Celsius, all of that, joules over grams, degrees Celsius, right? If for some reason something's not matching or anything else, it's probably because you didn't convert somewhere. So just make sure that you guys have your conversions and that your conversions are all squared away. Okay, so we are going to go ahead and we're going to get into a few of these equations, and then I'll talk about how to go ahead and how to solve these. Okay, so I'm going to go ahead, I'm going to do number 4. And it says, for number 4, calculate the specific heat capacity of a piece of wood that is 15,000 grams, and it absorbs 6,500 joules of heat, and the temperature changes from 32 to 57 degrees Celsius. So, first and foremost, what I'm going to do is that I'm going to, after I highlight, right, all my pieces, I'm going to go ahead and I'm going to start solving these deals. So I see that my mass is equal to 5 1,500.0 grams. I see that I absorb this much energy, so that's going to be my Q. And again, right, Q is just joules, and it's also absorbs heat. So you have to remember that Q is just heat. And then I have my temperature change, right? I take my last temperature, which is my final temperature, which is 57, and I subtract it from 32. And I go ahead, and when I do that, I should get 25 degrees Celsius, right? And then I go ahead and then I plug that into my equation. So I have 67500 joules is equal to M, which is 15,000 grams. I'm solving for the letter C, right? And then I have 25 degrees Celsius. So you guys have to remember that from there, you guys are solving for C. So very similar to if you guys are going ahead and if you guys are solving for X. Like I explained during class, there are two ways that you guys can go ahead and you guys can do it. You can go ahead and you can divide everything first and then go ahead and do the math, or you guys can multiply whatever you have going on at the top, like right there, right? And then go ahead and find the answer, and you guys will see that those are two ways to go ahead and to solve for the same thing. So I'm a little short on room, so I'm going to multiply first, and then I will talk about a little bit about how I go ahead and how I do this. So in this case, I have 1,500 times 25, and I go again, and I get 50 grams degrees Celsius times my letter C is equal to 67500 joules. I go ahead and I divide that so that I go ahead and again, I'm trying to isolate the C so I can go ahead and I can solve it. And that's the main thing that I'm trying to do. All right, so then I am going ahead and I'm going to divide these deals. So again, just make sure you guys are careful in your division because we don't want to mess that stuff up. So when you guys get this, right, C is equal to 1.8 joules over grams degrees Celsius. So that's what you get like spit out straight out of your calculator. But I want to go ahead and I want to express this in four significant figures, right? Because that's what I'm going to ask you guys on the test, right? So in order to do that, we have to go ahead and we have to make sure that this is 4 significant figures. So in this case, we're going to add 2 zeros after that. And we get that as our significant figures. Right, so again, the reason why I'm adding the zeros is so that we have 4 significant figures. Most of the cases, you guys will have to express it in 4 significant figures that way. I had another question on like one of the warm-up questions where it asked us like, oh, okay, Ms. Ponte, like if I had like 4,500 and like I think they wrote like 63.0 like 1. Like, how do I express that? And like, only for, oh no, it was bigger. It was a big number. She said like something like this. I don't remember exactly what it is, but then they asked me like, okay, like Ms. Ponte, how do I express this in 4 significant figures? In most cases, you guys are going to have to just round to get to 4 significant figures to kind of limit off the decimals. But in something like this, what you guys would have to do is that you guys pick your first 4. So 4, 5, 6, 3. Then I go ahead and I move that decimal point over. So I go ahead and count that 1, 2, 3, 4, 5 times 10 to the 5th. And then that would be my answer. If I'm trying to express a big number, but I doubt that you guys will have such a huge number. But in case you do, that's how you guys go ahead and that's how you guys would express that using that scientific notation. Okay. So next thing, phase diagrams. So your phase diagrams, you guys do need to like know like the 3 states and then how you get to each of the 3 states. So if you go from A to B, what you guys will see that this is a solid, right? This is my liquids, and then this is my gases, right? And then you guys just have to know how we go ahead and how we get to each of those states, right? So if we go from solid to liquid, right, we're going to actually freeze that deal. If we go from liquids, oh, my bad. Shoot. If I go from liquids to solids, I'm going to go ahead and I'm going to freeze. So if I go this way, I freeze. And if I go from solid to liquid, I'm going to melt. So that is how that thing works on there. Okay, and then going back into this, right, we have to go ahead and we have to think about what happens when we go from liquids to gases and what happens when we go from gases to liquids, right? So if we go from gases to liquids, very similar to what happens in clouds, we go ahead and we condense, right? And then if we go ahead and if we go from liquids to gases, we're going to go ahead and we're going to evaporate. So on your test, you guys should be able to name those things and to be able to draw the solids, liquids, and gases. So you should have a good idea on what are those different steps. And again, pretty much thinking logically through that. And then just so that you guys know, you guys will have a couple of questions that have to do with heat equation, that have to do with the heat of vaporization and the melting. Just know that it's Q is equal to MC. There's no delta T on there. It's just Q is equal to MC. So that is your thing on there. Okay, so alpha, beta, gamma, decay. So pretty much I talked about what happens in each of them. Now I'm going to show you guys how to go ahead and how to go through that problem. So in this case, I have americium. Right, 241 goes through a series of decays, and they ask you to do the math for the following. So I'm going to go ahead and I'm going to use my isotope formation. So I have 241 and 95, and I have AM. Right, it's going to go through alpha decay, and I know that because it's stated right there. So I goes 4 to alpha. And then I'm going to go ahead and I'm going to subtract those deals and I get my new element. So 241 minus 4, oopsies. So I have 237 and then 95 minus 2, which is 93. I go ahead and I look that up on the periodic table and I get that MP. Right, then I'm going to go ahead, I'm going to take this NP and I'm going to go through my next decay. So 237, 93, NP. I'm going to go through beta decay. And what I get is it still has the same mass of 237, but in beta decay, remember that we're adding. So I'm going to go to 94. Right, and that is going to be plutonium, which is Pu. I'm going to go ahead and I'm going to go through, take this back into beta decay again to the 237, 94. I'm going to go through beta decay. Right, and then since I'm going through beta decay, 237, 95, right, and I'm back to the americium. I'm going to take this and I'm going to go through beta gamma decay. Oh shoot, I didn't write the symbol right there. My bad, guys. And then I'm going to go through gamma decay. So that's what that looks like. And for gamma decay, you just kind of have to be able to leave it. And you guys will see that it's actually going to repeat. So 237, 95, AM, and then I go from my 4 to alpha, and then I'm going to get the 237, 93, NP. I take my 237, 93, NP, and I'm going to go through 4 to alpha again. and then I'm going to get 233, and then I'm going to go ahead and get 91, and I look up what 91 is, and it's PA. Right, and so that's what you guys would do. So just go ahead and make sure that you guys know all the symbols, right? Remember that beta you are adding, right, and alpha you're subtracting, and then for gamma it stays the same, right? So just make sure that you guys are able to kind of see those patterns. The patterns again on here always stay the same. You might see that they're expressed differently, such as this alpha can be expressed as an HE. So that's another way of going ahead and expressing those things. Okay, so ions. Ions, again, are just charged atoms. So these are just charged atoms. And in these charged atoms, you guys will see that there's a couple of patterns on here. Okay, so the thing to remember is that your number of protons are not going to change, right? Because if you change your number of protons, very similar to what we see in alpha, beta decay, right, you will also change the element, right? So in this case, I go ahead and I look at chlorine, and I find that chlorine on the periodic table is number 17, and that's just the number of protons or the atomic number for chlorine, right? Then I go ahead and I find the number of electrons. I see in this that I have a charge of 1 minus, right? So since I have a charge of 1 minus, that means that I have one more electron than I do protons. So I go ahead and I have 18 electrons in this case, right? So I'm going to just skip down and do another one. When you guys go ahead and when you guys do this, you guys will see that you guys have another one. So I'm going to do aluminum. So I go ahead and I find aluminum on the periodic table. I see that's number 13. I see that it has a positive 3 charge. So since it has a positive 3 charge, that means that I have 3 more protons than I do electrons. So in this case, right, I'm going to make sure that I have more protons. So in this case, aluminum that is like that is going to have only 10, right, electrons. Right, on this side, it's just pretty much the opposite that you guys have to do, is that you guys go ahead and you guys find the number on the periodic table. So I go ahead and I find 50 on the periodic table, and I see that 50 is tin, which is SN. Right, and in this tin, I have 4 more protons than I do electrons. So in this case, I'm going to have tin 4+, right? So that's how I go ahead and that's how I do that, right? And so in another one, right, so if I look at number 84 on the periodic table, I see that's polonium. So I have PO. I look at that and I see that I have more electrons than I do protons, right? So it's going to have a negative, and it is negative by 2 of them. So it's going to be polonium 2 minus, right? And then the 2 minus and the 4+, that's just like convention for chemistry. We usually write the number and then what charge it is. Okay, so for going ahead and for drawing these deals, my expectation is at this point that you guys can go ahead and you guys can tell me how many protons and how many neutrons do each of these things have. Again, I'm not going to go ahead and draw all of them. I'm just going to go ahead and go through some of them real quickly, right? So we're at the point where you guys can go 6 protons, 6 neutrons, right? Just put those deals in here, right? First orbital, you guys have to remember, has 2 electrons, right? And then for carbon, your second orbital has 1, 2, 3, 4. And if you guys draw something like this, good, done, right? And just make sure that you guys have everything that you guys need. So those are some of your things on there. And then last but not least is your periodic trends. They are asking you guys which one has a higher electron negativity. So we're looking for which atoms are closest to fluorine, because that is where our electron negativity kind of goes ahead and kind of lies. So in this case, fluorine is the most electron negative. Then they ask us to pair carbon and nitrogen. Since nitrogen is closer to fluorine, that one is going to have the higher electron negativity value. They ask us to compare magnesium and neon, right? Neon is not electronegative at all because neon doesn't count. So that one would automatically be Mg. And then they ask us to compare arsenic and calcium. So we find As, and we're going to go ahead and we're going to find Ca. So Ca and As. If you guys go ahead and if you guys find that, you guys will see. I'm having a little trouble finding As. Give me one sec, guys. So if you guys go ahead and if you guys look at that, it is going to be calcium. No, arsenic. So it's going to be arsenic. Okay, so those are going to be the things that you guys look at. Okay, and then our last couple questions, they want us to go ahead and to organize these in increasing ionization energy. So our first one is Be, Mg, and Sr. So I go ahead and I find that and I see that is in group 2. I have Be, Mg, and Sr. They're asking us to go ahead and go to increasing ionization energy. So when we're going for electronegativity and ionization energy, again, the trend is the same way for both of them. So we're going across and then up. So we want to have the one that has the most. So in this case, beryllium is going to go ahead and it's going to be the most. So increasing. So it's going to be SRMGBE. So that's what you get for that one. If you go from least to greatest. Then we're going to go Bi, Cs, and Ba. So Ba, Cs, Bi. So Bi is going to have the most, right? Because Bi is like over here, right? Cs and Ba are over here, right? Cs is going to have the least, and Ba is going to be right in the middle, right? And then the next one is sodium, aluminum, and sulfur. So sodium, aluminum, sulfur. So sodium is going to have the least, so it's going to be Na. Then it's going to be Al, and then it's going to be As. Right, so now we're going to go ahead and do increasing atomic radius, and an atomic radius is going to have a completely different trend. So you have to remember that atomic radius goes down, increases that way, right, and goes ahead and goes down that way. I don't like drawing it this way. And your biggest atom is going to be right here, which is going to be francium. So you guys are going to look for what is closest to francium. Okay, we have Mg, Na, P, and Si, and Ar. Okay, so we have Na. We have P, and we have Mg, and Ar. Okay, so Ar, argon is going to be the furthest, right? So Ar is going to be the smallest, right? Then I go ahead and I find Si. Si is silicon and then phosphorus. So if I keep on going across on my period 3, I see that I have Ar. Then the next one that I bump into on my list is phosphorus, so that's going to be my next smallest. And then I'm going ahead, I'm going to have silicon, and then I have magnesium, and then I have sodium. Right, so sodium is going to have the biggest, and then argon is going to be your smallest. So with that, that includes our semester 1 review. Congratulations, guys. It's been an absolute pleasure, and thank you so much, and happy studying, and feel free to contact me if you guys have any more questions.